know, that doesn't look like a S, but that's definitely an S. Sorry, that's an S. Okay, here we go. Let's have a little discussion. The first idea, parallel and perpendicular lines. What do you already know about, I don't know, let's talk about parallel lines first. What do you already know about parallel lines? Anything? Yes, spout it out. They never intersect. I agree. That's a great thing to talk about. They never intersect. Okay, what else do you guys know? Yeah. Yeah. Something about their slopes. The slope of two parallel lines has to be what? The same, yes. Two lines have to have the same slope. Yeah, and that could be two or more lines, right? I could have a ton of lines. I could have 50 lines that are all parallel in the plane, right? Anything else about parallel lines we should talk about? Alright, straightforward enough. What about perpendicular lines? What do we know about these ones? Let's talk about these over here. Perpendicular lines. They intersect once. Okay, very good. Yes, their slopes are negative reciprocals, REC, period. Negative reciprocals. What does that mean, negative reciprocals? You flip it. So what if I said one line has a slope that's equal to negative 2/3? What would the slope of a line perpendicular to that line be, Kekai? Positive 3/2. Yeah, so if I do slope perpendicular, that would be a positive 3/2. Now, here's the other thing you might not know. The product, what does product mean again? Multiplication. The product of the slopes of two lines that are perpendicular will equal, anybody know? If you just did that one right there, what would happen? What would you get? Not 0. -1. Very good. -1, right? Watch, if you don't believe me. What's negative 2/3 times a positive 3/2? It's -1. So this is a new way. You might not have ever heard this part before. The product of their slopes is -1 for two lines that are perpendicular. Question. I'm going to give you a line. I'm going to give you this line. Okay? There it is right here. And we'll scale it out, make it nice and big for you. And I'm going to put this point on the plane. Okay? There it is right there. You guys see it in blue? Yeah. All right, good. That's going to be our working example here. We're going to take this. We're going to bring it over to our notes. We're going to put it right here. Okay? So do your best to get this picture onto your page if you can. Okay? Something like that. So what was the equation that I gave you for this line? Do you remember what it was really quickly? Probably not. Yep. X plus 4y minus 8 is equal to 0. That's the equation of that line. And then I have this point over here, and that point is 3 comma -5, right? All right, here's what we want to do. Let's find a line, the equation of a line that is parallel to our red line and goes through that point. Okay, and goes through the point 3, -5. Everyone understand what we want you to do? Hello? Yeah? All right, great. What do we need to do first? We need the slope of that first line. I totally agree. What would it be? Let's see here. 4y equals, how about -x plus 8? Is that right? And then divide by 4. Yep, you got it. Divide by 4, divide by 4, divide by 4. So therefore, y must be -1/4 x and then plus 2. You guys cool with that part? So what is the slope of this line here? So the slope of that line is a -1/4. And we want to find the equation of a line that is parallel to it and goes through that point. So think about it. If I'm given a slope and a point, what form should I use, guys? I should use point slope form. Absolutely. Very good. So let's see here. What is point slope form? It was y minus y1 equals m times x minus x1. Right? You usually agree with that? Okay, good. What's the point that I'm going to use? 3, -5. Very good. So this would have to be y. Let's see here. If this is x and this is y, that's going to be y plus 5, huh? Equals the slope. What slope do I want to use if it's parallel? Yeah, the same one over here, at -1/4. And then I'm going to have an x minus a 3. You guys agree? Okay, good. Let's keep going with this, and I'll move up a little bit. So I'm going to get this. Y is going to equal, how about this? -1/4 x plus 3/4 minus 20/4. Whoa. What did I just do? Yes. Yes, I converted 5 to a fraction of 20/4 because I need common denominators to add them correctly. Okay, so cleaning this up, I get y is equal to negative 1/4 x. Let's see here, what would all of this be right here? Negative 17/4. Okay, so someone to remember that equation. Negative 1/4 x minus 17/4. So let's go back over here. So negative 1, what was it? And then what? Minus 17/4. Okay, now if we did this correctly, when we draw this line onto this graph, what should we expect to see? Yeah, we should expect to see a line that is parallel to the red line and goes through what point? The blue one. Let's see here. What would you guys think? Yeah, is that parallel to you? Yeah, there it is right there. Totally parallel. Absolutely. Okay. Caitlin, tell us what you got for the equation of a line that is perpendicular to our red line and goes through 3, 5. What'd you get?
Y equals 4x minus 17.
Y equals 4x minus 17. Okay, let's go check this, see if you got it right. So if I do y equals 4x minus 17, put this one on the graph there, and yep, I would agree. Yep, definitely perpendicular going through the point 3, 5, and awesome. Okay, here is box number 2 as an example, and I have a graph for you. So what I'd like you to do is I'd like you to look at this graph, and I want you to make a general statement about this graph in just a second, and then I'm going to ask you some questions about it, okay? Let's hear your general statements. Who's got one? Who can say any general statement about this whatsoever? Yes, Caitlin.
Well, there's more women than men living alone.
So apparently it looks like there are more women than men living alone. Okay. Do these two lines look parallel to you?
Yes.
Okay, yes or no? Josefa says no. Okay, what I would like us to do is interpret slope as a rate of change, okay? So these lines look parallel, so let's actually calculate to see if they are parallel. We're going to use the slope formula to do that, okay? I'll do women with you, and then I want you to do men by yourself, okay? The example. So the slope of the women, so I'll do, oops, I want actual red to match it. So we'll do slope of women, right? Is going to be, think about this is x1, this is y1, this is x2, this is y2. How do I calculate slope? You do the formula. So 17.2 minus 14.0, this is in millions by the way, all over 2005, take away 1990. Okay, who's got a calculator? Help me out. What's 17.2 take away 14? What'd you get? 3.2. Okay, divided by, how many years is that? Is that 15 years? Okay, good. So what would that be? What is 3.2 divided by 15? Help me out. 0.213. Okay, good. Everyone in this room, go ahead. Calculate the slope for men. Ready, set, go. Okay, how many came up with 0.246 for the guys? Okay, so even though these look parallel, are they parallel? No. Okay, so here's what I want us to figure out. So the rate at which men are living alone in the United States is climbing faster than the rate at which women are living alone. That's what this is saying. Do you guys understand? Okay, so I wonder at what year men living alone will surpass women living alone. Well, if you had to make a guess, what year do you think that would be? Okay, so ladies and gentlemen, I have drawn for you a very, very generic function on this page here. And how do you know this is actually a function? What gives it away? Pass the vertical line test. I love it. Very good. So, let's call this x1, and let's call this point over here x2. Fair enough? Okay, then what would this point be right here? If this is x1, what would this point be on the y-axis? So not y1, but instead of calling it y, we have a function notation. So this would be f of which x, to be specific? x1, very good. So what would this one be up here? F of x2, very, very good. Okay, now, the average rate of change is a very simple idea if you understand one thing. The average rate of change is the same exact thing as slope. Okay, so if we want to calculate the average rate of change between any 2 points, all we do is we take those 2 points on the graph and we connect them with something that's called a secant line. So take your straight edge right now, do your best to actually connect those 2 points as best you can. And this is called the secant line. And that secant line is the line that connects the 2 points that are in question here. Okay? So I'll make this dot a little bigger so it looks like go through. Okay, there you go. So the average rate of change, so average rate of change, I call it the AROC, the average rate of change, is nothing more than the change in y divided by the change in x, which of course is nothing more than the slope formula that contains the 2 points. So the slope formula would just be this, f of x2 minus f of x1 all divided by x2 minus x1. So you'll notice there, that's the exact same thing as what? The slope formula, right? So the average rate of change for this function between these 2 points, x1 and x2, is given by this formula here. Nothing more than the slope of the secant line that contains the 2 points. Okay, so I'm going to give you a function. The function I gave you was the square root of x. We want the average rate of change of that function between x equals 1 and x equals 9. So we have our function, f of x is the square root of x. I'm concerned with the average rate of change between the point x equals 1 and the point x equals 9. Okay? So I'm going to go onto my graph. I'm going to put a point at the output value of 1 and then go put a point on the output value of 9. That's what I want to do. Then I'm going to draw, what's the line called that connects the 2 points? I'm going to draw the secant line. So do your best to draw a secant line using a straight edge. So it would look like this right here, and that's pretty darn good for having technology based. Okay, good. I like it. Good. So this is our secant line. And we want to actually compute the average rate of change between those 2 points right there. So what are we going to do? Well, the average rate of change, which I'm calling AROC, is going to be f of x2 minus f of x1 all over x2 minus x1. So it's basically this distance, right? That's my change in y over that distance. That's my change in x. See it? It's nothing more than the slope formula. Okay? So how do I compute f of x2? Well, it's right here, right? So what would that be? F of x2 is what value? 3. Very good. What's f of x1? 1. Good. What is the value of x2 itself? 9. Good. What's the value of x1 itself? 1. Very good. So 3 minus 1, that's 2. That's 2/8, which reduces to what? 1/4. There you go. So the average rate of change for this function between the values of 1 and 9 is 1/4. We could have also just done this really cool thing called counting, where we go up to, and then we go over 8, and we see, oh yeah, that's totally right. But I want to show you that the algebra also supports your decision, right, that you've made. Okay? You guys find the average rate of change for this function for x is between 2 and 6. What's the average rate of change for this function between 2 and 6? And do you think it's going to be a higher rate of change or a lower rate of change than the one that we just found? So think about that. Okay, do that on your own. Okay, did you guys set up like this? F of 6 minus f of 2 over 6 minus 2? Yeah? Because those are the 2 points I have in question, right? Okay, what is f of 6? Well, that's the square root of 6. What's f of 2? That's the square root of 2, all divided by 4. Okay, what's the square root of 6 minus the square root of 2? I don't know. I bet my calculator knows, though. Alright, go get out of this. And go second square root of, what was it, 6, right? And then minus, oh wait, no, whoops. Get out of that. Delete. Whoa. Square root of 6. Minus, what was it? Square root of 2. Okay. Boom. Hit answer. So I'm getting that and then divided by what? Divided by 4. So I'm getting 0.2588. Does that you guys have? Okay, so that's 0.2588. And what's this? What's 1 divided by 4? 0.25. Okay, so 0.250. If we did that, is that okay? Can we do that? Okay, so which one has a faster rate of climbing? Between 2 and 6 or between 1 and 9? Between 2 and 6. Okay, so I'm going to give you this function. The function is going to be 2x squared plus 3. I want you to find the average rate of change between x equals 1 and x equals 3. So you can use your calculator to see what this is going to look like, but determine the average rate of change between 1 and 3 for this function here. Okay, so here's the function itself, 2x squared plus 3, right? And that's kind of a hard that's kind of a hard line to draw, right? But we're trying to take the actual slope of that secant line. So is this going to be a very steep slope or not a very steep slope? What does the picture say? This is a super steep slope, right? Really, really steep. Okay, so how do you go about doing this if the picture's all convoluted like this? What do you do? Yes, you're going to do f of 3, right, minus f of 1, all divided by 3 minus 1. Okay? Well, what is f of 3? How do you know what f of 3 is? You plug it in. What's 3 squared? Times 2 and then plus 3. What do you get?
It's 5. Or 21.
Yeah, 21 minus, what's f of 1?
It's 5.
That's 5, right? All divided by 2. So what would this be?
18. Yeah. Oh, just kidding. 18.
That's not...
Wait, what? No.
No, what are you...
8.
What are you guys talking about?
You said 18 and I was like, okay, yeah, you're right. The teacher.
Okay, what do you guys get? I'm asking you. 8 divided by 2 equals?
No, it's just 8. It's just 8.
Okay. Okay. I want you to go step by step. 21 minus 5. There you go. Okay, step by step so no one gets lost in the algebra. So what do we get? Okay, now interpret that. What does that mean?
18.
Yeah, who's saying 18? Yeah. What does that mean? The slope of what? The slope of that secant line between which 2 points? Between 1 and 3 is a value of 8. So 8 over 1. So up 8 over 1, right? That's what that means. Okay, take a look at this picture, everybody. This is, well, what is this actually? You guys tell me. What is this? What are we looking at? Okay, true. It's a function. What is it? What's a function of what? Height is a function of time. Time is in years, right? Age is in years, okay? So here's the deal, right? What I want it to do is, does this person grow at a linear rate? No, they don't. Some years they grow more than others, just like we do as human beings. Some years we grow more than others. So here's what I'd like to do. First, I'd like to compute the average, his average growth rate between the years of 13 and 18. On average, how many inches per year did he grow? I want you to calculate that right now. Anybody? Anybody? Say it. What do you got? Kenzie, what do you got?
He grows an average of 3.8 inches a year.
Yeah, so between the ages of 13 and 18, let's give this person a name. Roger. Roger grew an average of 3.5 inches per year. Okay, good. Here's what I want to ask you. Between which 2 years, here's the question, listen to the question very carefully. Between which 2 years, they don't need a consecutive, between which 2 years did he grow the most, or grow the fastest? What am I asking you to compute? The one with the largest slope. Who's got a good guess? Yeah, Josefa, what do you think?
0 and 20.
Between 0 and 20? So if I drew a line between 0 and 20, you think that's the steepest line you can find? No? Lauren, what do you think? Between 3 and 5. Between 3 and 4. Now check that out. Do you see a difference between the slope of this line and the slope of that line? Okay, what am I trying to get across? I'm trying to get across that slope can be interpreted as a rate of change, right? So the rate at which Roger is growing between the ages of, 3 and 4, that rate is greater than the rate at which he's growing between 13 and 18, because the slope of the secant line is greater. That's what I'm trying to get at. Does that make sense?
Yes.
All right, okay.